Hello and a very warm welcome to Weekly Current Affairs. Today is Saturday and we are going to take up the current affairs that have been covered in the last 1 week, which have been figured out in various newspapers and some magazines. My name is Madhusudan Reddy and I will be taking up the miscellaneous components for this week. So as you all know that this is a weekly series. In this weekly series we cover up Monday to Saturday with various different subjects, starting from Monday and ends with Saturday. And on Saturday we take up the miscellaneous components that have not been covered out in the earlier subjects, right? So today we are going to take up few different articles which are very relevant for the UPSC examination, and the chances of asking these questions in the examination is also very high. So that's why we take up these miscellaneous components here. Now the first miscellaneous component that have been figured in the newspaper is one of the storm surges. Along with the storm surge, there is also in relation to the Fujiwara effect. Okay, Fujiwara effect, this has been published in the Down to Earth article, and the other article that has been explained in the various newspapers regarding the new continent, that is large continent which is going to be formed in the further 200 to 300 million years. Of course we don't be alive by then, but the changes and the dynamic nature of the changes in the continental drift, we have to understand that. So that is your Amasia. It is simply saying that Amasia is one such big continent where there is no Pacific Ocean in the future time period. So let us understand how is this Amasia going to be formed and who gave this concept and where exactly are the changes that we are going to see. So this is an explained article in various newspapers. So one of the newspaper which says that Amasia, the supercontinent that will be formed as the Pacific Ocean sinks. Calculations by scientists at the Australia's New Curlin University, it has revealed that Amasia will be a combination of present day American and Asian continents together. That means in the future Pacific Ocean is no longer going to be there. So in this contest, for the examination, from the prelims point of view, you have to know what is Amasia in the recent times seen in the newspaper, or else Amasia is a combination of American or Asian continents, and what are the back arc effect which has been talked about in this article. So firstly we'll quickly move to this article and then we'll go for the Fujiwara effects. See, as you all know, there's a big theory, very famous theory, which is always there in your NCERT, that is your continental drift theory, which has been given by the Wegener in the initial time period. He said that there used to be a big continent called Pangaea. It used to look like this, and after that, over a period of time, this Pangaea has been divided into two different continents, and the sea between them, it is called as Tethys Sea. And later, the current time period, which is the modern world, we call it, where the continents are displaced at various distances. Now over a period of time, India was also once part of this Gondwana land. Now this is your Gondwana land, which says that India, which is once present here, slowly started to move to the Eurasia, and when it has struck or collided with these Eurasian plate, that is when the Himalayan mountains and other various landforms that have been formed. So in this due process, what we have to understand is the technicalities behind the formations of these landforms. Here we need to know clearly how exactly is the Amasia going to be formed, and let us try to understand this through the small video. Okay, let's see in the further time period how are the changes going to be seen. Australia, it is understood that it is going to collide with the eastern part of the Japan, and in this article they said that the Pacific Ocean is going to sink. So if at all Pacific Ocean is going to sink, what are the changes of landforms that you will get to see? And this is given by one of the university called Curlin University. See, firstly they have been talked about existence of the back arcs. Back arcs are going to trench in the near time. Firstly, let us know what exactly is a back arc, and then where are they present and how are the changes that we are going to see in the Pacific Ocean. See, in the Pacific Ocean, it is clearly evident that most of the Pacific Ocean is not a plain area, and you can also see this is the ocean bottom topography of the Pacific Ocean, where there is a line. This line is called the trench. Now trenches are nothing but whenever an oceanic plate and a continental plate, when they collide with each other at the converging boundaries, that is when the denser material will start to sink to the bottom, and it sinks to the mantle and then it starts to melt there. That leads to the formation of some volcanoes. Let us try to understand how this process is going to take place and what are the changes that you will be seeing in the further time period. Firstly, before this, let me tell you, our earth is a pieces of plates. These pieces of plates, they continuously move. These pieces of plates are floating on the asthenosphere, right? And asthenosphere is one such layer within the earth, which is a plastic like molten like material, which is neither solid nor liquid. On this, these continents are balancing themselves. You see here, let me show you a plate. The plate here is the Indian plate, and this is your African plate. Like this, the globe is divided into multiple plates. So it is said that the Eurasian plate is going to collide with the North American plate in the near time future. While happening, there are some back arcs which are there. They are the ones which are going to extinct in the near time future. It is said that these two continents are going to merge together in 200 to 300 millions. But if you see here, there are some land masses which are present next to each other. That is, you see, most of the coastal area of the eastern part, they are the ones which are going to see the changes in the near time future. Now, what kind of changes are they? Let us try to understand. In this context, firstly, we should know about the concept of back arc. Now, what is a back arc or back arc basin? Let me try to show it on the map. Are there any back arcs in the Pacific Ocean? The answer is yes. In the Pacific Ocean, the South China Sea is called as a back arc basin. Why is it called a back arc basin? Because see here, the Philippines, South China Sea, whatever you are seeing, that is, there is a sea here and there is a sea here. How come these islands have been formed? So this is called, South China Sea is called as back arc basin, and this is your Pacific Ocean, and these are called as back arc continents. Now this article says that the back arc continents and the back arc basins are the ones which are going to shrink in the near time future. How are they going to shrink? Let us see. For this, you need to have a basic understanding regarding the plate tectonics theory. Here, the plate tectonics theory says that there are some plates. These plates keep on moving from one place to another place. Today, the rate of movement of the Pacific Ocean plate, which is completely an oceanic plate, Pacific Ocean plate is an oceanic plate, and this oceanic plate is moving around 7 centimeters per year. And this is the fast moving plate till date. It is moving at 7 centimeters to 11 centimeters per year. On an average, 7 to 11 centimeters. This is one of the fastest rate of movement of the plates you'll get to see across the world. If you see the Indian plate, the movement of the Indian plate is not much. The oceans here, the Indian plate moves from 5 to 3 centimeters per year. Sorry, 5 to 7 centimeters per year. But the rate of movement of the Pacific Ocean plate is more. And you look into the Atlantic Ocean, the rate of movement is hardly 1 to 3 centimeters. Just a minute, guys. It is only 1 to 3 centimeters. This is Atlantic Ocean. So that's why it is said that Pacific Ocean is the first one which is going to extinct. Right? How is this going to happen? Let's see here. Now let us assume there is a continental plate and there is also a oceanic plate. Imagine this is your continent. Okay? Right? And imagine this as Asia. And then you also have ocean beneath it. Imagine this is your ocean, oceanic plate. Right? Let me draw it in a different way. This is your oceanic plate, and this oceanic plate, the thickness is hardly, you'll see, somewhere around 5 kilometers of thickness, but here you'll see the thickness of somewhere around 30 cell acre, 70 kilometers of thickness. Though the thickness of the continent is thick enough, but they are not denser. This is less dense. But whereas oceanic plate is more dense. Here you have to understand that whenever a denser plate collides with the lighter plate, at these conditions it will start to the denser plate will start to sink down. Imagine this is your denser plate which is having more density and a thickness of 5 kilometers, but being this more denser, it will start to sink down. For your imagination, let me draw the water also. Imagine this part of the continent is beneath the water. And this is your continent, some part of the continent which is also submerged under the water. Mostly this is called as your continental shelf, and this is your oceanic plate. Imagine now this is your Pacific Ocean, right? And this is your Asiatic region. And this Asiatic region and Pacific Ocean, while they are moving towards each other, this is where there is a collision that takes place, and this plate is also moving and this plate is also moving. They are trying to collide with each other because this boundary is called as converging boundary. Now what does this article say? This article says that there are some back arcs that are present. Now what are these back arcs here? See, back arcs simply means whenever the oceanic plate which goes into the mantle and melts off, it will start to give out some volcanoes. Imagine the mantle went into 2D, the mantle present which is at somewhere around, just imagine it is present at few kilometers beneath the ocean. So as soon as the oceanic plate starts to melt in the mantle which is present beneath, it will start to melt, and this melted material will start to rise up, right? And they'll start to break the continent. When they start to break the continent, here is where you'll have volcanic activity. If this volcanic activity is taking place within the ocean, they are called as oceanic volcanic mountains. And if this volcanic activity slowly over a period they have raised above the surface of the ocean, and here it is then these will start to cool down over a period of time. Now see here, the Philippines, this can be your Philippines, Taiwan, whatever the continents that you see across the South China Sea, they are called as back arc continents or back arc continental mass. Now this is your Pacific Ocean, this is your continental area, and this can be your Philippines. But see here, there is still water present between the continental area and also within the interiors of the continent. So because of this, this basin which is filled with water is called as back arc basin. Now imagine over a period of time what happens is that in this area, for some reasons, imagine there is a river that is originated on these volcanic mountains. Now for your imagination, what you have to do is, the size of these mountains can be hundreds of kilometers wide, big, which can continue this process for near about thousands of years or around. This will turn out to be one of the biggest land masses. And on this, just imagine that there are some rivers present. So what happens? This river, it can also flow from this direction, and it can also shed its water in this direction into the sea, and this turns out to be shallow sea. यहाँ पे river will start to bring in sediments, and the depth of the river, it will reduce. Now this is your shallow sea. Why? Because there are some sediments that have been deposited by the river over thousands of years. Now we are talking about the continents that a formation of Amasia in the upcoming 200 to 300 million years. But what the article was mentioning about is the back arcs formation will be very, very fast, and also the shrinking of this back arcs will also be at a very faster rate. So now this back arcs, if at all something is going to get melted, it is the first one is your South China Sea and the Philippines. Why? Why? See here. Now just imagine the same on our map. See, the Pacific Ocean is also moving towards, this is your Pacific plate and this is your Eurasian plate. Eurasian plate and Pacific plate, when they started to collide, it is actually the Pacific Oceanic plate which is having more dense. This is more dense. As this is more dense, it starts to collide with the continental plate which is less denser. So whichever the particle is more denser, it will start to sink down, and as soon as it sinks, it will go and melt in the mantle. While melting it, it will bring up the volcanic activity, and that volcanic activity has led to the formations of your Philippines region. And I told you this is your back arc basin. That means this is your continental shelf. Most of the continental shelf oceans or seas, they are called as marginal sea. Now what do you mean by marginal sea? See, marginal sea is one sea which is most of its area is present on the continental shelf, right? That is your marginal sea, and this is also called as your back arc basin. So the difference between back arc basin and marginal sea, not all back arc basins can be your marginal seas. There can be marginal seas without back arc seas. One such example is your Baltic Sea. Look here, the Baltic Sea, most of its area is located in the continental shelf. Now to identify the continental shelf here, there is a difference in color, right? There is dark blue color and this is light blue color. This is all your continental shelf. Continental shelf is nothing but an area that is extended into the ocean, and this area is not having too much deep. The water will not be too deep. Most of the ocean is present on the continental shelf, this sea. So this is called as marginal sea. North Sea is a marginal sea, but it is not a back arc basin. Now this article says that in the upcoming years, this entire landmass of oceanic beneath the ocean, it is going to sink beneath the oceanic floor, the continental floor, and then in the sooner or later, in the upcoming 200 to 300 million years, it is going to form a big landmass, that is your Amnesia. Let us see this again. I think this will now make better sense to you, the same video. It is, the credits will be given to the Curtin University, because this Curtin University is the one which has given this theory, and it is been circulating around the newspapers. See here, it is Australia, again South America, North America. It is the ocean of Pacific Ocean which is going to sink. When this Pacific Ocean which is sinked, that means all the landforms which are formed in the Pacific Ocean, they are going to sink beneath the mantle. That means there is new landforms which will be formed somewhere on the other part of the planet, and they are going to be together again, right? So this is the article which talks about, and most likely if at all a questions that can be asked, it can be asked regarding few other aspects, that is your Pacific Ring of Fire. What is Pacific Ring of Fire? How come this Pacific Ring of Fire bring the changes in the current in the plate tectonics theory? So here and all you can quote these examples, and most importantly it is back arc basins, because back arc basins can be a short note directly asked in your general studies mains, because last year there was questions about the water masses that have also been asked. Now let me also tell you what is Ring of Fire. Pacific Ring of Fire is an area across the Pacific Ocean wherever you find trenches. That means this is your area of the trenches which is present in the Pacific Ocean. These trenches are formed because this is entirely the oceanic plate. This oceanic plate, it is moving outward, so it is colliding with the Eurasian plate. So that is why you also get to see back arcs here, and the back arcs are the ones which are going to die soon as per the Curtin University report. So in this context, let us also see the number of trenches that are present in the area. See, the more number of trenches are present in the Pacific Ocean. The deepest trench, I think you already know, it is your Mariana Trench or the Challenger Deep which is present here. And let us look into the Tonga Trench. This is the one which has been in current affairs because of the evolution of the Tonga volcano in the 2022. And you also have Aleutian Trench. Aleutian Trench is a group of islands where you get to see here, they are also present next to the trenches. This is your Aleutian Trench. And Izubonian Trench, which is present across the Japanese coast near the Japan. Kurilyi Trench, or you also have Ovesho-Kuresho Trench current. This Ovesho-Kuresho current can also be seen next to this trench itself. And the western coast of the Peru, it also has a trench, it is also present on the trench. That means intense earthquakes you can get to see across the western coast of America and western coast of South America in the near future. And this landmass over a period is also going to sink. So all in all, though we might not be there for the near future to witness all of this, but a good article that can be discussed and for the UPSC examination to be asked. Now let us move for the next article, and before we moving to the next article, let us first discuss what exactly is this article talking about. See, this article is published in the Down to Earth. In the Down to Earth this month, it is 15th, 1st se lekar 15th October. There are finest articles. Please also go and read those articles if you do get time. And we also come up with these kind of articles discussed in the miscellaneous topics also, right? So one such article we are going to discuss now. This article which talks about the Fujiwara effect makes cyclones more unpredictable due to their rapid intensification carrying of more rain and newer ways of moving over warming oceans. Though this is a very big sentence, but let me tell you what exactly is this. See, whenever two cyclones meet with each other, that is when the effect is called as Fujiwara effect. Now what is this Fujiwara? It is the name of a scientist. The scientist has identified that whenever these two cyclones, when intense cyclone and a non-intense cyclone, when they come and meet with each other, that effect is called Fujiwara. Now the scientist also says that this Fujiwara effect can happen when the cyclones are not far away than 1000 kilometers or 900 kilometers or around, and they should be present somewhere near to each other. Two cyclones should not be more than 13-degree latitude away from each other. So in this context, let us see, are there any cyclones which are been Fujiwara'd in the last 1 year? Do we have enough data? What kind of weather effects we will get to see, and what kind of changes in the local area you are going to witness? So before you understand here, let me tell you there are two tropical cyclones that have been in news in the 2022. That is Hinan, More and Gardo. This have made good news which are across the area. Firstly, these two tropical cyclones are present across the coast of Japan. So in this Japanese coast, especially in this year itself, 2022, hardly in the month of September itself, it has been talked about. So these two cyclones, they came towards each other and they mixed with each other. They together turned out to be not a devastating cyclone, but usually these kind of effects will bring out very strong cyclonic storms, right? Now you might be asking, what is a storm, or what is a storm surge or cyclonic storm surge? This has also been in news. So first let us see what is a storm surge, and then after we'll think of cyclones, and after understanding cyclones I'll tell you the Fujiwara effect. Before this, let me show you a small video of 10 to 20 seconds which will give you an impact of storm surge. Now what exactly is a storm surge? You might be thinking storm surge can be of a small water particle area that comes into the land. No, storm surges is nothing but whenever a cyclone that comes onto the continent, and the cyclone will bring in lot of water from the ocean. So this will lead to the devastations, flooding like situation, catastrophic events, loss of life, and this has been in news in the last 1 week itself. That is Helen tornado, a tropical cyclone which was there, that has created a storm surge. Let us see the impact of this storm surge last week, how it has created. You might have come across this video. This video has been in circulation. This is Helen tropical cyclone, which is also called as tornado in their local area, or hurricane in the western coast of USA. See here, these storm surges are very harsh, huge. This is a time-lapse video. You might be thinking that the depth of the wave can increase by 1 meter. No. At times it can also cross somewhere around 3 to 4 meters. The water can inundate inside. Though it is not a tsunami, it is a storm surge. In India also, on an average, yearly one storm surge we will get to see. But the rate of intensity of this storm surge is not very harsh. Now, if at all I ask you what are the very disastrous effects or economic impacts of this storm surge, I think now it is clearly visible and I have made some sense to you. See, storm surges, they come there, they bring in their water, and also by the end of a day they go back. So this is a short activity. In this short activity you will understand that you will see that these activities can be not far-fetching. Only for half a day, 1 day, they come in the morning and they go back by the evening. This is not a tsunami too, but it's a storm surge. The economic impacts of storm surge is very much seen across the coast of India also. So before this, why do we have these storm surges? You first need to understand tropical cyclone, and also you need to understand the if you want to understand the Fujiwara, you also need to understand the tropical cyclone. So first let us quickly get into what exactly is a tropical cyclone. See, a tropical cyclone is a cyclone which is present between 5 degrees north to 5 degrees north to 20 degrees north or 30 degrees north, and 5 degrees south to 20 degrees south. If this is your equator, 5 degrees north and south, from here 5 and then you'll get to see near about 25 degrees north and 25 degrees north and 25 degrees south. This is the area where you'll get to see the tropical cyclones, right? and at times they can also extend up to 30 degrees. Extend up to 30 degrees as well. Now beyond this you won't find tropical cyclones. If at all you find any cyclones, they are called as temperate cyclones. The characteristics nature of a tropical cyclone and a temperate cyclone is completely different. See, temperate cyclones are formed because of the air masses, but tropical cyclones are formed because of the latent heat that is being released into the atmosphere. Firstly, let us quickly discuss what is a tropical cyclone. See, a tropical cyclone is nothing but a stormy air which moves at least with a speed of 50 kilometers or greater, and then the wind along with the good rainfall enters into the coast. So for its formation it needs some basic conditions. These basic conditions are nothing but, firstly, it should have around sea surface temperature of 27 degrees Celsius. Now this 27 degrees Celsius sea surface temperature, it should be present somewhere around for near about 150 meters deep. If this is your ocean, in this ocean the sea surface should have 150 meters deep and 20 to 30 kilometers area with an eye. This can be from 10 to 30. This area of water should be having 27 degrees Celsius temperature of minimum. And then there is continuous rising of air, or this continuous rising of air in the form of evaporation, that is through latent heat concept. Then the same air should also have a diverging limb as it reaches the tropopause, right? At times the air that rises cannot rise beyond the tropopause and also cannot diverge in the sense it cannot go outward. In those conditions what happens? The clouds form and they rain. This kind of rainfall is called as convectional rainfall. At the equator every day you'll get to see this, but cyclones, they are not formed at the equator from 0 to 5 degrees Celsius, because a cyclone also need to have Coriolis force, right? Firstly, the conditions for the formation is 27 degrees Celsius, and then there is rising air. This rising air should not have much of a speed variation when it reaches to the top and when it is at the bottom. That means there should not be much of a wind shear. The speed of the wind, it should not vary much at the surface at the top layer, and also it should have Coriolis force. The area should have Coriolis force. That means presence of Coriolis force should be there. Presence of Coriolis force, and also the sea surface temperature of 27 degrees Celsius. Upward air divergence, that means as it rises there is a tropopause, it reaches the tropopause and the air should start to diverge in all the directions, right? This is your upward air divergence, and there should not be no wind shear. Wind shear is at the surface the wind direction can be in one side, and a little more higher the wind direction can be in different direction. This is also called as wind shear, or else the variation of speeds as you go higher into the atmosphere, that is also called as wind shear. Here you need to know these are the bare minimum necessity for the formations of a tropical cyclone. Along with that, the eye will be having a calm subsiding air, and because of the presence of this Coriolis force, whenever there is low pressure, when the winds are moving from high pressure to low pressure, the winds will start to turn around. Now how is this turning happens? See here, you have a low pressure area, and this low pressure area will start to attract winds from all the high pressure area. Imagine you have high pressure here, high pressure here, high pressure everywhere, and this will start to pull the air from all the directions. That means the movement is from always high pressure to low pressure, right? So here what happens, because of the presence of the Coriolis force, which is towards the right in the north and towards the left in the southern hemisphere, all the winds in the northern hemisphere, they turn towards their right. They have a deflection. This deflection over a period, if you see, they tend to make an anti-clockwise direction circulation. This anti-clockwise direction circulation is the one which is making the tropical cyclone to spiral, right? These are the bare minimum requirements. And a tropical cyclone which is present in the northern hemisphere, it will always be under the influence of easterlies. These easterly winds, they drag the tropical cyclone onto the coast of India. And it is not just India, all the tropical cyclones, most of the tropical cyclones, they move from east to west. Why do they move from east to west? It is because if you know it, please comment in the comment section. It is because the presence of the westerlies and the presence of easterlies. So from 5 degrees north se lekar near about 30 degrees north tak, you actually have easterlies. Easterlies are the winds which come from east to west. Under these influences, they'll start to move towards one direction, right? That is easterly direction. So see here, this is the proper structure of a tropical cyclone. A cyclone is well developed, it starts to spiral up, it starts to rise, and there is upward divergence of air in all the directions, and a tropical cyclone cannot rise beyond the tropopause. So some air which has been risen, that also goes into the interior, that means to the center, and this air forcefully starts to sink. That's why you also have subsiding warm air in the eye, and it also develops some kind of rain bands. These rain bands are nothing but those clouds which have gone far away, they'll sink at the time, right? That means the clouds have been raised and then the formations have been happening in the bandwise. So these are your rain bands, and this is the proper well developed tropical cyclone. This tropical cyclones, imagine like this, you have two different tropical cyclones which is also spiraling, and the strength of the tropical cyclone here is primarily because of the evaporation. If the rate of evaporation is very fast and harsh, the movement of the cyclone will also be very fast, and the strength of the cyclone will be also very equally strengthy. Now let's see what exactly happens in the Fujiwara. See, Fujiwara is one such situation where both of these tropical cyclones, if they are not far away from each other, near about 1000 kilometers की odd range पे होना चाहिए, number one condition, and the number two condition is that they should not be far away from each other. Did we see these tropical cyclones which have converted into Fujiwara in the near time? The down to earth article says that in Indian Ocean it has happened in 2015, 2017 too. Now when it comes to the recent happenings in the 2022, it is clearly visible that the Fujiwara effect has been found in the east coast of Japan and little south of the Japan. Now this is two cyclones, that is Hinamore and Gardo. This is the satellite rendering of the movement of the tropical cyclone, that is Hinamore and Gardo. Hinamore has devoured the Gardo. There are two tropical cyclones, let me clearly show it to you here. These two tropical cyclones, they merged towards each other. Instead of turning out to be a mega cyclone, what happened here was this cyclone has nullified and the intensity has become down. Now it is very difficult to understand the phenomena of this process because we have limited data regarding the Fujiwara effect, right? See here, let me again show you what exactly is happening. This is one cyclone, this is another cyclone, this is Hinamore and this is Gardo. The Hinamore has as a more strength cyclone, and overall this cyclone has pulled another cyclone. They together should actually become a mega cyclone and bring in storm surges like the one which we have seen. But to our surprise, the same cyclone has dissipated and the strength of the cyclone has reduced. Now this is a new kind of phenomena in geography which is beyond our understanding, means it is beyond the scientific understanding, because it is said that the article says that we do not have much data we do not have. It is said that we only have the data for the Fujiwara effect only for 10 to 15 cyclones in the last few decades, right? The first one, it is in the 1964, only in the year 1930 to 1940 we started to observe these phenomena, and with the changing climatic trends, it is now understood that the impact of these kind of cyclones, when two cyclones can merge, the climate change phenomena will intensify these kind of phenomena, and previous understandings of this Fujiwara effect has led to large scale destructions and devastations across the coast of Japan and even in the Indian coast as well. So let us see the recent Fujiwara effects. See, the first one is Typhoon Hinamuna and Tropical Storm Gardo in the Western Pacific Ocean in the year 2022. Now before that you also have a Cyclone Varnam and tropical storm which is 93S in the Indian Ocean in 2022 itself. That means you got to see two Fujiwara effects, one in Indian Ocean, other one is Pacific Ocean. Now these are both present in the tropical latitudes, right? So because of that, it is intensified. In the same year, if you are getting to see two tropical cyclones, that too they are Fujiwaras. That means collectively these are 4 tropical cyclones. They have conveyed or converged together to form 2 Fujiwaras, and another Fujiwara is waiting. It is just south of South America. It is not understanding, the scientific community is not able to understand because it is currently in the ongoing process. You can also visualize it on the various satellite images by rendering them. Now this is the data that we have. First big problem is that in order to understand these Fujiwaras, we do not have much of a data. That means when you do not have a data, you cannot analyze the upcomings, right? Now these are the challenges. Along with that, there are some technical terms, though these can be asked for geography optional students also. It can also be asked for, maybe the processes can be asked for this. Let us quickly see how exactly 2 cyclones mix with each other and what are they called. At times a cyclone which is more stronger and a cyclone weaker, this more stronger cyclone will start to pull the less stronger cyclone. So these are called as weak interactions. Now the weak interactions, which are also called as elastic interactions. Under the elastic interactions, suppose you have a one cyclone, bigger one, small cyclone, that tend together to form an smaller cyclone. This elasticity is more in this. The vortices or storms of same different sizes, when they tend to come together, the devastation will not be of much strongness, right? It won't be of much strength. Now the second type of interaction which you will get to see is partial straining out. That is, let me write it here. The second one is partial straining out. It is called as PSO. Now in this PSO part, interaction will happen between vortices of unequal sizes. Unequal size, 2 tropical cyclones, one is small, one is big. The interaction will be of unequal sizes. Now when it comes to the complete straining out is nothing but whenever there are interactions that is happening for unequal sizes, that unequal size cyclones, the smaller vortex completely lost to the atmosphere. That means a smaller cyclone, it will be dissipated into the atmosphere because the bigger one eats away. That is your CSO. And last one is partial merger and complete merger. Complete merger are the ones which are very strong. When they merge it, they generally tend out to be forming a very big tropical cyclone. They are called as mega cyclones. So these mega cyclones, whenever they come, it is highly understood that they are going to get in the storm surges. Okay. Now storm surges can also come along with the super cyclones. Super cyclones are those cyclones whose speed is 120 से ज़्यादा, 120 जो किलोमीटर से ज़्यादा स्पीड है, they are called as super cyclones. In India we had 1997 super cyclone, 2001 super cyclone, and the recent time Hudud is one such super cyclone we have got to see in 2015. So at times the coastlines of India can also have these kind of Fujiwara effects, because you look into the Bay of Bengal, on an average this is the season the most of the cyclones you will get to see from September, October and November. So in this durations, you will at least see some 4 to 5 cyclones forming in the Bay of Bengal. At times, the cyclones that are formed a little north, they also tend to mix with each other. Hopefully, we should not be seeing much of these kind of interactions, because these can bring out a mega cyclone can impact more. Now what kind of changes it gets, it is not completely understandable to this scientific community yet, but we should be watchful for these kind of understandings by getting in more data from various aspects. So let us quickly see how exactly is this happening. See guys, this is a small rendering which we have tried to show it to you from the internet. So now what happens to these tropical cyclones, it completely depends upon their interaction. A big cyclone can take away the small cyclone and then they start to interact with each other. Once they interact, one can eat away and the smaller one can also merge with the bigger one, and that can also be eaten away. The interactions are very much confusingly disturbed and not much clarity is there for the scientific community. But there are some cyclones that have developed into a mega cyclones like this one, but at times the dissipation has also been seen in the case of the previous one cyclone, that is your Hinamore and Gardo. So overall, this is your Fujiwara effect. What we have to look forward is the storms for UPSC examination and the principle of the Fujiwara effect. So I hope I have given some kind of sense to your preparation through these topics. And please make sure to subscribe to our channel. If you like these videos, please let us know. We'll be motivated to come up with more better content. And also, please make sure to answer a question on these topics. A question will be posted in the description below. And also for the PPT of this, you can download it from our Telegram channel, that is Raj Malhotra IAS Telegram channel. And also, if you do have any doubts, you can also call me, you can also message me, no calls please. You can also message me at this contact number, that is my name is Madhusudan Reddy. Thank you guys. Please make sure to answer the Seize the Mains question, which is free of cost. You will be evaluated at free of cost by our evaluation experts. Thank you and see you next week.